right. Let's see if this is working. All right. Can't tell if it's working, but we can try it out in incognito real quick. But, aha. Alright, so today we will be working on reviewing some Unit 2 math material. This is your host, Mr. Ham, Math 2 Sensei, coming at you live with our first review session on YouTube live stream. Hey, I see we got a viewer already. What's up, Maya? Nice to see you. Alright, so, Unit 2, first off, it's about congruence and similarity. So we really want to be focusing on our shapes here, focusing on our angles, and making sure that we are able to solve for those angles and prove when stuff is congruent and when stuff is similar. Alright, so let's take a look at this problem. This was one of the problems from, can't remember which exit ticket, but it's one of the exit tickets from before. So we're given this shape and we want to figure out what our angles are going to be, right? Let me take this off here. Okay, so give me 1 second. Uh-oh, it's not what we want. Alright, okay, so, we want to figure out what these angles are going to be. So, like I've said to a lot of folks in tutorial, my number one tip for these kind of problems, these angle problems, is to always start alphabetically. So, definitely start with T in this case, We want to start from T, work our way all the way through Z. Usually the alphabetical order will give us sort of a hint as to where to start, So let's take a look at this problem. We have an angle T right here, and we got to figure out what to do. So there's 3 sort of strategies that we've used in this class in order to figure out our angles. So we have our first strategy is going to be parallel lines. So that's going to be using parallel lines in order to find our angles that correspond, our opposite, interior, alternative, that kind of good stuff. Alright, our second strategy is triangle angle sums. Alright, so remember, the angles of any triangle are going to add up to 180, Any triangle with 3 corners, those 3 angles of the corners are going to add up to 180. So that's a big one. The third and last one is supplemental angles. So supplemental angles, they just mean when you have something that forms a line, you're going to get 180 degrees. So let's take a look at our example here. And if you are watching live, be sure to drop something in the chat. It should be on the right side of the video. So if you have any questions, always feel free to pop something in the chat. Alright. So without further ado, right, we want to solve for t. Now, this problem has no parallel lines, so automatically we can just get rid of this strategy, right? We don't have any parallel lines. So we're going to be really focusing on these two. So for angle t, right, first off I noticed that there's 3 triangles here, right? One triangle, middle triangle, third triangle. And, well, I mean, we could use our triangle angle sums to figure out our angles, but there's a problem, right? Let's look at this left triangle here. So I want to figure out what t is, but how do I go about doing that? Well, I could set up an equation, right? I want to say the 3 angles, so t, u, and 39, when I add them together, they're going to equal 180. But how do I solve for t, right? Because we have a problem. If I try to solve for it, I'm going to get something with a u in the answer, and I don't know what u is, so that's not going to really help me, right? So, alright, I can't use that triangle, but are there any other triangles that include angle t? The answer is yes, right? I could draw a bigger triangle around the 2 triangles inside. So what about this, right? I could do t plus 43 plus, this angle would be a combination, right? It would be 39 plus y equals 180, but again, right, I have an unknown variable y that I can't solve for, so this wouldn't help me. Alright, what about the last triangle? What about this giant triangle on the very outside edge? Right, this could actually help us, right? Because we have 32, we have this big angle, and we have t. So what is the big angle? Well, if you look closely at the problem again, you'll notice there's this red box here, right? This box means that the angles it forms a 90-degree angle, a right angle, right? So we know that 39 plus y plus z is equal to 90, okay? So what will we do? We'll set up our equation, right? T plus 32 plus 90 equals 180. Alright, so next I'm gonna move all my numbers to the other side, right? So I can isolate that t, so 180 minus 32 minus 90, right? I gotta move it to the other side, so I'm switching the signs. That will give me 180 minus 122, which gives me an answer of 58. Alright, so my answer is going to be 58 right here. Got a question in the chat. Is our test going to be hard tomorrow? Well, I would say it depends on how hard you study. So like I said in some of our classes, right? The test, so first off, the test is only 45 minutes to an hour. So it's not going to be nearly as long as the review problems, right? Second thing, I'm just gonna keep it real. I'm not a very original person, so a lot of the problems you'll see on the test will be problems you've likely seen before, just slightly changed, right? So based on how you're studying, right, how you're reviewing, whether you understand the concepts or not, right, that's gonna be what determines whether the test is difficult or not. So that is my sort of advice to you, right, to study up. And that's what this review session is for as well. So if you have any questions as I'm going through it, feel free to drop them in the chat. I'm glad you're using the chat effectively, so that is good. And also let me know if you're liking this format of studying, I guess. Because this is the first time I'm doing it, but I mean, if you like studying while watching a live stream, then we can definitely do more of it. Alright. So, back to our problem, right? We have angle T. We have figured out angle T. It is 58 degrees. We used our big triangle to get our two known angles here. And we solve for the missing one, which is 58. Alright, so what do I do now? Well, I can use the information I just got to solve for my next angle. Right? Let me put this back here. So my next angle that I could solve for could be in this triangle, right? I already solved for T, so now I can solve for U, right? Because we said T plus U plus 39 should equal 180. So now I can do 58 plus U plus 39 equals 180. U equals 180 minus, that's what, 97? So U would equal 83. Alright, so now I have U equals 83. So we have another angle complete here. So 83. And right, if any of this is, for example, if the math or anything was confusing, you can always pause the video, pause the recording, pause the live stream, go back, and then catch back up afterwards. Alright, so we have U. What's our next one? Our next one should be V, right? And V is actually a little bit simpler. So taking a look back at our strategies, right? If we want to solve for V, I could solve it using the triangle here, but I don't know what Y is, so what am I going to do? Well, I could actually use supplemental angles in this case, right? Notice that U and V form a straight line, like this, right? So one way to think of it is if I had a little, like, clock hand, like this, and I rotated it V degrees, right? It would end up here. If I rotated it another U degrees, it would end up here. So in total, the clock hand makes a full half circle revolution, right? It goes from one side to the other side, which is 180 degrees total. Right? So that's what we mean by supplemental angles. So what does that mean for V? That means we can solve for V by saying that V plus 83 equals 180. Rearrange the numbers. V equals 97. Alright. So yet another angle solved. We have V equals 97. And we're just going to keep going, right? So next up, we have our V now, so we can solve for Y. So that would be 97 plus 43 plus Y equals 180. Y equals 180 minus 140. Y equals 40. Alright. So boom, Y equals 40. Keep it going, right? What about X? Well, X is supplemental to 43. So 180 minus 43 should be 137. So there we go. X is 137. Last angle is Z, right? So Z, you could figure out two ways. The first way is you could notice that this makes a triangle. So 32 plus 137 plus Z gives you 180. The other thing you can notice is that Z plus Y plus 39 should equal 90. So if I were to take 90, subtract 40 and 39, I would be able to get my Z. So let's do it that way. So Z plus 40 plus 39 should equal 90, right? Because they form this right angle. So rearranging it, Z equals 90 minus 79. Z equals 11. Alright. So now we have solved for all of our angles here, right? Started from this, and we worked our way through each angle in order to get all of them solved. Alright? So that is the strategy when you want to use, right? You want to use your three main tools: parallel lines, triangle angle sums, supplemental angles. And you'll be able to solve for all of these angles just by looking at what you have and using those three basic rules to just keep finding more and more answers. Alright. So that was a problem from one of our previous lessons. I had a couple questions that were sent to me, so I'm going to be reviewing questions 4, 7, 11, and 12. So if you are watching this from the recording, you can pause the video, do those problems on the review, and then watch the video after you've finished, and then check your work. If you're on the live stream, then go ahead and work through them as I work through them. Alright, I got a question in the chat. When are the grades going to be final? So test is tomorrow. Grading of that test will be done this weekend, hopefully. And your tentative overall grade with all the Unit 1, all the Unit 2 stuff will be posted in PowerSchool this weekend. Then the final, the day the grade will be finalized is next week. So next Friday, October 6th. So you'll have all of next week to turn in old assignments, redo your test, do what you gotta do to get your grade up. So you'll have that much time to do it, alright? Now, because this is a quarter exam, the way we might redo the tests will be a little bit different than last time. So keep that in mind, right? You don't want to just flunk this test for no reason. Make sure you're paying attention, make sure you're studying, make sure you're doing well on this test so that you don't have to put in too much work next week. Alright? Okay. So we have question 4. Alright, so for question 4, question 4, we have the following diagram. And we want to do the same thing as before, right? We want to start with A, work our way through the alphabet, and find our numbers. Alright, so starting with A, right? What can we say about A? What do we notice? This angle right here. So remember, our 3 strategies are 1, parallel lines, right? Which we have 2 of those in this problem. We have parallel line, parallel line. Second strategy, triangles, right? The triangle angles sum up to 180. Third strategy, supplemental angles, right? Any 2 angles that form a line add up to 180. So let's see, let's look at A. If you notice that A and 48 are supplemental, then you would be correct, right? That would be where you start. So A is going to be 180 minus 48, which is 132. Alright, so we have A now. What about B? B, if you said B is the opposite of A, then you would be correct, right? Remember, opposite angles mean that the angles are between the same 2 lines. So for example, if I highlighted this in blue, this in red, right? Notice the 132, right? The A is between the red and blue. This is also between red and blue, right? Whereas 48 degrees is between red and blue here, but H is between blue and this black line. So these are not opposite angles, right? However, B and A are opposite angles. Okay, so because they're opposite angles, right, and we know opposite angles are congruent, B is equal to 132. All right. So remember, so far we have 132, 132. What about C? So for C, notice that we have 2 parallel lines and we have a transversal line going through them, right? And what did we say about angles where they match up with each other, right? Well, they're corresponding angles. So B and C are corresponding angles, right? If I were to take angle B and move it down here, it would match up exactly the same. So what that means is angle C is also 132. Alright? So far we've been using supplemental and parallel lines. What about D? Let's look at this stuff. So you might be tempted to say, oh look, there's like a triangle here, right? We could do 132 plus D plus H, but we don't know what H is, right? So keep that in the back of your mind. If you said that D is supplemental to 151, you would be correct, right? D should be equal to 180 minus 151, or in other words, D is 29, right? Same thing with E. E is the opposite of D, so E is 29. F is the opposite of the 151, so it's 151, right? Now we loop back here. So what is angle G gonna be? So let's think for a sec. This one's a little bit tricky, but let's think for a sec, right? So whenever you have an angle that's on a parallel line, try to find where this angle would be on the other parallel line, right? So we have this parallel line, and the other parallel line is right here. So can I find this same angle on the other parallel line? The answer is yes, right? If I were to hold up. If I were to take this angle and move it down here, what do you know? You notice that E is the same as G. Hey, what's up, Chanel? Thanks for the chat. Glad you could pop in. If you have any questions, feel free to use the chat. Alright, so like I was saying, right, E is going to be the corresponding angle to G, right? Same line on different parallel lines. Alright, so G is corresponding to E. Another thing you could look at is G forms a Z shape right here on these parallel lines. So what does that mean? Well, remember, when you have a Z shape, we said that this gives us an alternative interior angle pair. In other words, G is equal to D. So G is equal to D or E, right? Those are both 29. So G is 29. All right. So now we have our very last angle, angle H, right? Two ways to solve this as well. So one, you could notice there's a triangle here. And you just got to take 180 minus these two. And whatever is left over is H, right? The other way you could do it is you could go back to our opposite angles talk from earlier. So 48 is the opposite of these two angles combined, right? G and H. So in other words, G plus H should equal 48. And we know that G is 29. So H should equal 19. Alright. So now we finally have all of our angles solved. Like so. So remember, right, we started off right here. No, not even. We started off right here. And, right, with just those two numbers, we were able to solve all of these other angles, right? So that's really a powerful concept that, you know, in geometry we can use just our logic to figure out all these other angles. Right, because ultimately it's not really about math, right? It's not about calculating numbers and stuff, right? It's about thinking, okay, well, I know this, therefore I know this, therefore I know this, therefore I know this, and this, and this, and this, yeah, right? So that's the real skill here, is identifying where the pieces fit in the puzzle. All right. So next requested question, number 7. So first thing to note, right, these kind of questions are algebra questions, right? The skill is not being able to solve these per se. Like, I mean, obviously you have to do the math to solve them, but the real key skill here is how do you start, right? How do you start? So for example, for this problem, right, we want to figure out how the 3x and the x plus 20 are related such that we can set up an equation to solve them. So what do we notice about this angle and this angle? What do we notice? So if you said that they are equal to each other, that would be incorrect, right? First off, you should realize this is an acute angle, this is an obtuse angle. Not the same. Not the same. So, okay, so they're not equal. So what are they then? Well, if I were to... What if I did this? So what if I take this angle and moved it up here? Ooh, right? Perfect fit. What you realize is this top angle is corresponding to x plus 20. In other words, this top angle is also x plus 20, right? This right here, x plus 20. Okay, so now we know that this angle is x plus 20. What do you notice now? So now you should notice that these form a line, right? These are supplemental angles, right? Angle here, forms a line. They add up to 180, all right? So what you want to do when you're doing these problems is first figure out the relationship, then state that relationship in algebraic terms, all right? So if I said 3x equals x plus 20, what does that mean? That would mean that that angle 3x is the same angle as x plus 20, as this angle. However, we just said that they are not equal, right? This is acute, this is obtuse, there's just no way that they're equal, right? Then I said, okay, well, I know that they gotta add up to 180, so how do I set that up? How do I express that in mathematics? Well, I'm gonna say that their sum, so x plus 20 plus 3x, right? That combined expression is gonna equal 180, right? Just like that. So x plus 20 plus 3x equals 180. Combine like terms. Move the 20 to the other side. Right, and x should equal 40. Right, 160 divided by 4, x equals 40. All right. So remember though that 40 is not the actual angles, right? The actual angle degrees are when you plug 40 back in. So for the example, this angle, it's not 40, right? This is 3 times 40, which is 120. Right? What is this angle? It's not 40. It's 40 plus 20, so 60. Right, so now when you have these numbers, 120 and 60, now you can instantly realize, oh, well yeah, duh, of course they add up to 180, right? 120 plus 60, it's 180. So that's all that we're really doing, right? We're taking these expressions and we are expressing their relationship algebraically. That's all we're doing. So for each of these problems, right, the real key skill here is to quickly be able to identify what the relationship is and how you set it up in math. So this one, right, these are supplemental angles, they add up to 180. So I would add them together equals 180. This one, they're alternative interior angles, right, they form a Z. So I'm going to set these ones equal to each other, right? I'm not going to add them. This one we just did, right? They are supplementary. They add up to 180. These are also called consecutive interior angles. These ones are opposite, so they're equal. This one, they add up to 90, so they are... so you're going to add them together to get 90 instead of 180. This one, right, the 3 angles add up to 180 because they're in a triangle. Alright, I see a question. Is that a sheet grade? Could you explain your question / clarify what you meant? That would be much appreciated. This review thing, this was posted in Google Classroom. I can actually also send the link in the chat, I think. There we go. So yeah, that link will take you to this review guide, right? This is just a guide to help you practice. It is not graded. It is not graded. So this is just to help you study, right? It's a bunch of different problems to help you study. When you press the submit button, like let me answer this as like 1, for example, right? If I press submit, it'll actually give me, yeah, you can press the view accuracy and it'll actually give you all the answers for the practice problem so that you can like check your work, all right? So make sure you do that. All right. So anyway, that's it for question 7. We have 2 more requested questions. So question 11. All right. How are we doing, viewers in the chat? How are we feeling about the test so far? Any questions, any comments, any concerns? Go ahead and type out a little message in the chat so we can gauge the audience here. Maya, how are you liking the live stream? Is the live stream good? Is it helpful? What do you think? Good and bad? Yeah, that's how it be. That's how it be. It's the math exam life. All right. Okay. So for this next problem, right, this problem is problem 11. Oh, cool. Say hi to your uncle for me. Shout out to Maya's uncle here. Okay, so for problem 11, right, the problem you want to solve is what is angle x, right? What is the degrees? So the key skill here, right, is to figure out what do I need to solve, what other angles do I need in order to get to x, right? Where do I start and where do I have to get to? So, right, remember that we have 3 strategies: parallel lines, triangle sums, supplementary angles, right? So looking at this problem, right, I want to find x. What can we notice about x? Like what can I see right away that might give me a hint as to how I solve for x? So if you said the 90-degree angle, that would be correct, right? You should notice that we have a 90-degree angle right here, right? The square is the right angle. And the x is inside of it. So the x is smaller than 90 degrees. So we already know that. But more specifically, we know that x plus the purple angle adds up to 90, right? So if I were to put that in an equation, right, x plus purple equals 90. So if I were to turn around and solve for this, it would be 90 minus purple, right? So great. Now we actually know exactly what we need in order to solve for x, right? We just need purple. We just need to know what purple is, and then we'll be able to solve for x. Alright, so how do we solve for purple though? Right, that's another problem of its own. So we want to solve for this angle. Right away you should notice, oh well, there's a triangle over here, right? I could use that. So I could say purple plus 31 plus, what's our third angle? So purple, 31, it would be this one, right? This obtuse angle right here. I'm gonna put as a question mark. When I add those up together, right, those should equal 180. So purple would equal 180 minus 31 minus whatever this other angle is. Okay, so now I know, again, right, if I want to solve for x, all I gotta do is solve for purple. If I want to solve for purple, now all I need is to solve for a question mark, right, which is right here. So this whole question now boils down to, what is this question mark, right? What is this angle? I'll give you a second to see if you can figure it out. If you answered 118, then you would be correct, right? The question mark plus 62 equals 180 because they're supplementary, meaning question mark is equal to 180 minus 62, 118. All right, so now we know, right, the question mark's 118, so purple should equal 180 minus 31 minus 118, which is the same as 180 minus 149. So purple, now we know, is also equal to 31. Alright, so remember, we found the question mark. Now we can find the purple, right, using our triangle. Now that we know purple, we can use our complementary angles to solve for x. So now we know x is equal to 90 minus 31. X equals 49. All right. And there you have it. That is your answer. X equals 49. So to recap, right, we were given just this, just two numbers. We looked at this problem and we said, all right, how do I solve for x? What do I need in order to solve for x? And I said, well, I need to solve for purple, because once I know purple, I know that x is just 90 minus purple. Then I said, how do I solve for purple? I just need to know this, because they form a triangle, and I can, right, solve for purple using the triangle equation. And then I said, how do I solve for this? Well, this is supplemental to 62. And then I just worked my way backwards. All right. So that is how you solve these sort of problems, right? Again, not very math heavy. Very much a puzzle, right? It's all using your logic, right? Using your reasoning to solve these problems. So, you know, I would say if you ever feel stumped about these problems, right? Don't count yourself out, right? This is not a math thing, like, I can't do math, like, I can't, like, do whatever, right? It's not about that. It's more about, right, just taking a deep breath and thinking through, all right, which things can I use, right? What can I figure out? And then work your way from there. All right. got a question. Could you tell me what my grade is now in your class and tell me what I can do to make it better? Alright, so I will message you later privately so that your grade isn't posted all over YouTube. But yeah, I can certainly let you know how you're doing and what strategies you can use to improve it. All right. All right. Okay, and our last requested problem was number 12. Okay, so number 12, in the figure below, 5 lines intersect as shown, right? L is parallel to M is parallel to N. What is the value of X plus Y? So, right, the question is really, what is X and what is Y? So let's look at this, all right? So we want to solve for X, this obtuse angle here. What can we look at here? How can we solve for this number? We're only given 2 numbers here, 50 and 60. What can we do to increase our information and, right, figure out the next step of the puzzle? So if you said use corresponding angles, that would be correct. So notice, right, for example, line, right, parallel lines right here. This angle corresponds to this angle, corresponds to this angle, okay? Meaning, this is 50. This is 50, all right? Same thing here, right? Parallel line, parallel line, parallel line. This corresponds to this, corresponds to this, right? If I were to move these down, right, that's exactly what they would be. They would all be 60 degrees. So this is 60 degrees, this is 60 degrees. Okay? So now what? Well, now you notice this problem has become a lot simpler, right? This is just supplemental. So X is the supplemental pair to 60, so X should be 120, right? Y is the supplemental pair to 50, so that should be 130, right? It's just 180 minus whatever this is. And there we go. Simple as that, right? So again, same thing, right? It's not about the math, it's more about looking at this problem and thinking about what you could possibly figure out from it, right? I mean, I could keep going, honestly, right? I don't have to stop here, right? This is 60, this is 50, right? This is 50. I already figured out X and Y, so I know, right? This is 130, 130, 130, 120, right? 120. I could figure out what this is, right? This is just this minus 50, right? I'm taking out 50 from what this angle is. And remember, this angle is just 120, right? Because it corresponds to this and this. So now I know, oh, look, this is 70. This middle angle is 70, right? This middle angle is 70. This angle, what is this angle? This is 60. Right, what about these? Well, we can use opposite angles here, so this is 50, this is 60, right? 50, 60, and there we go. We've solved for basically every single angle in this entire diagram with just 2 numbers. So again, right, the math part is not terribly complicated. It's really about using, right, what you know about parallel lines, about triangles, and supplemental angles to figure out, you know, what steps you need to do to get to these 2 numbers, right? Instead of wasting your time solving for every single angle on this entire map, you just want to solve the right steps in order to get to X. Alright. So that is it for the requested problems. I'm going to do a couple more just so that that is available to you. So first off, similar triangles, right? This one is fairly simple. So so you're trying to figure out the width of a river. The Boy Scouts or whatever have placed stakes at the end of the river and here, right? And notice the key here is that they form 90-degree angles with the river, which makes these triangles similar, okay? So it's asking, what is the length of MT? Well, all we have to do is figure out what's the scale factor, right? We have a big triangle and we have a small triangle. So what do I multiply the small triangle by to get the big triangle? That's all I have to figure out. Well, we can look right here, right? There's 100 here and 400 here. So clearly, if I multiply 100 by 4, I get 400. So if I want to get this to become this, I multiply by 4. Then to get this, all I have to do is multiply this by 4. Says I'm experiencing some issues. Let me just make sure it looks good. Okay. Alright, should be fine. Okay. So like I was saying, right, 100 to 400, right, I just gotta multiply by 4. So in the same sense, 75 times 4 should be that, right? And 75 times 4 is going to be 300. Alright. So that's it for that. And that's going to be a very common theme for a lot of these problems, right? For similarity problems. Like, right? How do I go from 3 to 30? I multiply by 10. Okay, then how do I go from 2 to the unknown length? I also multiply by 10, right? I just gotta scale it up. So the tree here is gonna be 20, right? Simple as that. Alright. One more problem about proofs. And then I think we'll end the live stream. Alright, so for number 2, right? This problem is going to be very important in terms of, right, understanding how you prove, how you, how you do proofs, right? Whether it's congruence or similarity proofs. So let's see what it says. The figure to the right has length or side AB is congruent to side CB. Okay? So what that means is this side and this side are the same length. They're congruent, right? And angle A is congruent to angle C. So boom, boom. Right? These two angles are the same. Okay? Now, the third thing that the problem doesn't tell you, but you should automatically see, is that BM is a shared side on both triangles. Meaning they both have side BM, so like they're congruent, right? Because it's the same side, it's the same length. So the question is, which of the following proofs would be used to prove that triangle ABM is congruent to triangle CBM? So real quick, right? When we talk about congruence, we have 4 different proofs: SSS, SAS, ASA, and AAS. When we do similarity, we have SSS, SAS, and AA. So notice when it's 2 angles, right? It's kind of like combining these two, right? These both have 2 angles. And you're just sort of getting rid of the side pair. So anyway, we're not dealing with similarity, so let's just focus on congruence. Right? What do these mean? What they mean is I need 3 pairs of either sides or angles that are exactly the same, that are congruent, right? So for example, I have this side is equal to this side. So I have 1 pair of congruent sides, right? They are the exact same. They're 1 pair. Another pair is BM and BM, right? Because both triangles have BM, right? This triangle has BM. This triangle has BM. So that is another pair on both triangles where they are the same, right? And then we have an angle. We have this angle and this angle. They're the same, right? It's a pair. So we have 2 sides and an angle, right? Remember that order matters. So we have side, side, angle, right? It's not side, angle, side. It's side, side, angle, right? Which would be this, right? Wrong. SSA, if you notice, is not included on this list. The reason is, well, we won't get into it too much in this video, but SSA isn't enough to prove that you have a congruent triangle. Because you could have 2 sides like, say it's like this, right? And then an angle. You could also have it like this, right? So even though this side is the same, because we don't know the angle of this top part, right, we end up with different triangles. Meaning, just because we know that we have S, right, 2 S's and an angle, doesn't mean we have the same triangle. Okay? So bottom line, SSA does not work. Remember, right, we don't want to use this because it spells a naughty word when it's spelled backwards. So we want to stick with the 4 here. Alright, so right off the bat, SSA out of the picture. Doesn't prove congruence. HL we haven't learned about yet, so we're not gonna deal with that. And right off the bat, let's check for SSS. So we have two side pairs. What about this third pair, right? AM and MC. Are they congruent? So one thing a lot of people say is, yes, AM and MC are congruent because they look the same, alright? And to those people, I say no. Absolutely not. No, sir. We do not use the L word in this classroom. We do not use look in this classroom, okay? Look is not a logical proof, alright? We want to use a real reason, right? Parallel lines, corresponding angles, supplemental angles, right? Whatever. You want to use those to prove something is congruent or something is similar. You do not want to use the L word, alright? This is forbidden. This is the L word. If you use this word on your test, you will take that L on the test. So do not use that word. Alright. So, bottom line, we do not know if AM and MC are equal. We can't tell. There's no, right? It doesn't say anything in the top part, right? There's nothing that shows us that these are equal. There's nothing we can do, right? These angles, they don't prove that they're equal, right? There's just nothing that proves that they're equal, right? Because if you think about it, you could draw other triangles. Like I could draw this kind of triangle, and it would still match this description, right? AB is the same as CB, right? These match. Angle A is the same as angle C. These match. BM is shared by both triangles. But what do you know? This is longer than this, right? So you have to only work with the description you're given. Okay? Alright, so we don't know AM and MC are equal, therefore we do not have the third side. So this is out. No SSS for us. That leaves us with these three. So can we do SAS? So remember, this is SSA. What about SAS, right? Where the angle is in between the two sides. So can we prove that this angle, angle ABM, and this angle, angle CBM, can we prove that these are congruent? If you answered no, that would be correct, right? So again, we're gonna avoid the L word like the plague, alright? Just because they appear the same doesn't mean that they are the same, right? These angles are not necessarily congruent, and there's no way we can prove that they are or are not, okay? BM looks like it's splitting this triangle in half, but we have no idea. There's no way to tell, alright? So, we don't have that third angle. We cannot do SAS. Alright. ASA, well, right, again, we can't use this, so no ASA for us. The last one's AAS. So what about, right, we already said this angle doesn't work, but did we check our last angle? What about this angle, right? This angle and this angle, are they the same? If you said no, that would be correct, right? Again, I could draw the same triangle that fits the description, but draw this thing like this, and suddenly these angles are not the same, right? So based on the description, I have no idea whether these angles are equal or not. So we can't get another angle pair, and it won't work. So none of these work. None of these work. So the answer is not necessarily congruent, right? What does that mean? It doesn't mean that they are not congruent, right? Clearly they do look like they're congruent, right? It just means that we can't prove that they're congruent, right? It's asking to prove 100% sure without a doubt that they're congruent, and we cannot, okay? We have no idea whether they're actually congruent, whether it's just slightly off, whether the diagram is just tricking us, right? We have no idea. So, not necessarily congruent. That is the final answer for number 2. All right. So that will be it for today's review session, for the live stream at least. So thank you everyone for watching, whether it was on the live stream or on the recording. I think this hit about like an hour long, which is long, but hopefully it was helpful to you. Please make sure to subscribe to the YouTube channel in case you want to get notifications when I go live again, or just, whenever I post a video from class. And otherwise, if you are watching this before the test, I wish you the best of luck. Please do study hard and study a lot from the review problems, because these will help you unequivocally. Alright, so that is it for the lesson. Thank you everyone once again, and I will see you next week. Alright, take care. This is your Math Sensei signing off. Yeah, I really appreciate it, and I will see you soon.